Hello everyone. In this recording, we try to solve the second exercise, production planning. So here is a scenario. We have a factory that can produce up to 6 products. Each product requires a certain number of machine hours and yields a profit. The factory can use at most a limited number of hours, and at least 3 different products must be included in the plan. Select the set of products that maximizes total profit while satisfying the feasibility rule. And we have this time we have 2 rules. One of them is that we should make sure that the total hours is less than the limit, and the number of selected products should be at least 0, greater than or equal to 0. And the task is that we need to implement the exhaustive search algorithm to find the optimal solution of this problem, and we need to apply it to 3 different instances. So we have the small, medium, and large. So we try to have the code for this problem, and then I'm going to run this code and execute it for the small and the large one to see how our algorithm and code behave. So let's go to the Colab. So here, as you can see, we have the hiking trip merged. This is the final piece of code that we had for the hiking trip problem, and we are not going to do the same thing for the production planning, and we are going to use this one and modify this one for our new problem and solve that problem. So first I'm going to generate a copy of this hiking trip, and I'm going to call it what's the name, production planning, or yeah, this is production planning. So production planning merge. So this is so first, as we see for the previous exercise, we need to get some input from the user. So in this case, we should ask the number of products, and also ask about their required hours for each product, and also their profit and the limitation. So we have to ask 4 different questions. We need 4 parameters for our problem. So how many items do you have? We can modify this. How many products do you have, which is going to be n, and then we ask for, we can replace this item rate with required hours, and make sure that we change the item rate in your code. So we have the item rate here, we use it once here, so it's going to be the required hours, and we don't have anywhere else. And please enter the products required hours, and then we have the profit. So we can have products profit, and again products, and then we replace this one with the item value here, and we can please enter the products profit. And finally, instead of capacity, we can replace this one with limited hours, or the hours that we had, or any other wording that you prefer, but is the available number of hours. And then we have the solution, we have the best value, we have the best solution, so everything is the same. So we use the binary representation. So our solution is going to be a vector or a list of zeros and ones, and everything is the same. So we have the solution weight. So for example, we can have solution instead of weight, we can have solution required hours, and the solution value could be solution profit. And then what we do here, the solution weight, which we don't have it anymore, which is required hours. The solution required hours is, we are updating this in this for loop, and this is going to be the required hours. This, so we go item by item or element by element using this this list of parameters multiplied by the solution corresponding item. And then if the solution required hours, we are checking the feasibility here, is less than the capacity, which is in this problem is the limited hours. In this case, we satisfy one of the rules or the constraints that we have. What is the other constraints that we have? If we go back, we have to first make sure that the total hours, which is our required hours, is less than the limitation or the upper bound that we have. And the second one is that the number of selected products should be greater than or equal to 3. So in this case, if we go back to our code, we need to update this feasibility check, this if statement. So we need to make this one true, and at the same time, we have to make sure that the number of products is greater than or equal to 3. So how we can calculate the total the total number of products? So our representation is a binary. So if you remember from the previous code that we had the sum of for example, the result, sum of something else. So that sum is going to add up the elements or the items of the list. So we can say here, we can use that sum of what? Solution. So if the sum of solution is greater than or equal to 3, we satisfy the second constraint or the second rule. So this is the second one, and this is the first one. And this if statement is true only and only if this and this is true. If this one is true and this one is true, that the if statement is true, and then we start calculating the objective function of that solution. So in this case, we are looking for the solution value, which is in our case is solution profit, and we're updating the solution profit using the products profit, this list multiplied by the solution. And if the solution profit is greater than the best value that we have so far, then the best solution will be using the solution.copy to replace the previous best solution, and the best value, which is going to be replaced by the solution value, which is the solution profit. And then in the last part, we update our solution, which means we go to the next solution. So here we need, after again out of this big for loop, so the best, so we can say, let's say the maximum profit is, and this is going to be the best value, and the best selection is this. So let's see if this one, 20 sessions, and I don't need this one, and I also don't copy of, this is the one that we're working on, so I don't need this one to close. And let's see if it works. Yeah, so how many products do we have? So we go for the small one, we have 4. Let me write those values here. So we have 4 products, and it is 6, 3, 4, 5, and the profit is 10, 6, 7, 8, and the limitation is then the hours are 15 minutes. So we have 4 products. Required hours are 6, 3, 4, 5, and the product's profit are 10, 6, 7, 8, and the limited hours is 15. And we again have a problem. So the solution, and again I have a typo here, where is the solution? And in the if statement, yes, the sum of solution. Yep, so this is the one. And if we run again, 4, 6, 3, 4, 5, and 10, 6, 7, 8, and then we have 15. So this is the maximum profit is 25, and the best selection is the first, third, and the fourth one. If we go to the problem definition, the first, I forgot it, it's the first, third, and fourth. So 6 plus 4, 10, plus 5, 15, so it's less than or equal to 15, and we actually chose 3 products, which is the minimum requirement, and the profit equals 10 plus 7, 17, plus 8, 25. So let's do this for the large sample to see. We actually do not calculate the exact computational time, but let's see how long does it take to solve this one. So the hours is 2, 3, 4, 5, 6, 3, 2, 4, 5, 7, and the profit is 4, 6, 7, 9, 10, 5, 4, 7, 8, 12, and the limitation is 25 hours. Let me double check, and we are good to go. So let's run this code again. How many products do you have? We have 10 this time, and the required hours are 2, 3, 4, 5, 6, 2, sorry, 3, 2, 4, 5, and 7, and 4, 5, and the profits are 4, 6, 7, 9, 10, 5, 4, 7, 8, 12, and the limitation is 25. So here is the thing, the profit is 45, and this is the selection. So it was so fast, so there's nothing to be worried about. So we have the second, third, and the fourth. We have three of them. And finally, we have 8, 7, 8, and 10. So we have 6 products, which is more than 3, which is our constraint. And if you go back here, we have 2, 3, 4. 3, 4, 5, it's 12. We have 12 hours here. And we have 8, 7, which is 6, and 12, 18. And we have 7, which is 25. So we use our maximum capacity or maximum available hours, and the profit is the summation of the corresponding items. So 6 and 9, 15. So this is 22, and 22 and 11 is 33, and 12 it's 45, which is the value of our objective function provided by the code. So this is the end of this recording. I hope you enjoyed. Thank you so much.